Good morning, students. Today we'll continue with few properties of inverse trigonometric function. One is tan inverse x plus tan inverse y is equal to tan inverse x plus y 1 upon x, 1 minus x plus y upon 1 minus xy when xy is less than 1. And the second is it is pi plus tan inverse x plus y upon 1 minus xy when x and y both are positive and xy is greater than 1. And second is tan inverse x minus tan inverse y is tan inverse x minus y 1 plus xy when xy is greater than minus 1. We'll see the proof of the first part. Now when xy is less than 1, the first case. So what we'll do, we'll assume tan inverse x is equal to a, tan inverse y is equal to b, and we know that a and b has to be from minus pi by 2 to pi by 2, then only we can write, because they are the inverse, the principal value branch. So now we can write x is equal to tan a and y is equal to tan b, and we know the formula from class 11. Tan a plus b is tan a plus tan b upon 1 minus tan a tan b. Put the values of tan a tan b, so we are getting x plus y and 1 minus xy. Now whether we can transfer this tan this side, that we have to see. For doing that, we need to check the values whether this a plus b is from minus pi by 2 to pi by 2 or not. So we know xy is equal to less than 1, so it means tan a tan b is less than 1, and tan a is what? Sin a sin b by cos a cos b is less than 1. Now since a and b, they are minus pi by 2 to pi by 2, it means fourth quadrant and first quadrant. Minus pi by 2 to pi by 2 is what? Fourth and first quadrant. So we know cos a and cos b, they are positive in these two quadrants. So cos a and cos b is positive. If it is positive, it means we can multiply the inequality by a positive number. It will not alter the inequality. So we are multiplying. After multiplying, we have got that sin a sin b is less than cos a cos b. Or we can write cos a, transpose this on the other side. So cos a cos b minus sin a sin b is more than 0. What is the formula? Cos a plus b. It means cos a plus b is more than 0. If cos a plus b is more than 0, it tells us that a plus b is in the fourth or first quadrant, or we can say it is from minus pi by 2 to pi by 2. Now we have authenticated that a plus b is from minus pi by 2 to pi by 2. So we can write a plus b as tan inverse. This part is important for you to understand. Even in some of the cases you are not required to show, but you must check whether when you are taking the inverse, so the value has to be in the principal value branch. So this was the first case. So we have got the tan inverse x plus tan inverse y is tan inverse x plus y 1 minus xy. Now the second case, x and y both are positive, xy is more than 1. So if you take the reciprocal, y x is positive, 1 by x has to be positive, y is positive, so 1 by x is positive. Now xy is greater than 1, so you are taking the reciprocal here, so 1 by xy has to be less than 1. Now if 1 by xy is less than 1, so we can write this in this form: 1 by x into 1 by y is less than 1. Now from the first we'll apply the formula. What formula? Because here you have got that case that xy is less than 1. This is x, this is y. Now understand in this way. So tan inverse x plus tan inverse y, we can write as we have proved in the formula ahead. So we can write it is 1 by x plus 1 by y, 1 minus 1 by x, 1 by y. So now we'll simplify this. So you will getting xy means x plus y, xy here minus 1, and xy will get cancelled. So you are getting tan inverse x plus y by xy minus 1. Or you can write, if you take minus common from here, so you are getting x plus y by 1 minus xy. And this side, we know tan inverse 1 by x and tan inverse 1 by y. We have already seen that they can be written in terms of cot inverse x, cot inverse y. So we are getting that tan inverse, we have already written it, and cot inverse x can be written as pi by 2 minus tan inverse x. Again, pi by 2 minus tan inverse y. If you add, you are getting pi and minus common, tan inverse x plus tan inverse y. And this side it is minus tan inverse x plus y upon 1 minus xy. So what you are getting finally, the tan inverse x plus tan inverse y is pi plus, take this on RHS, this on LHS, so you are finding this. It means this formula is also very important. So now we'll just see how do we apply. Take a question. We are having a question. Evaluate this sine inverse 12 by 13, cos inverse 4 by 5, tan inverse 63 by 16. So what we'll do, first we'll convert this sine inverse and cos inverse in tan inverse. As earlier we have discussed this. We'll assume let sine inverse 12 by 13 is A. So sine A is 12 by 13. We'll take the triangle into account. So 12 by 13, it is sine. So apply Pythagoras theorem, it will give you 5 here. So we can write tan A is what? 12 by 5. So A is what? Tan inverse 12 by 5. It means sine inverse 12 by 13 can be written as tan inverse 12 by 5. On the same way, you can write cos inverse 4 by 5. Again take the triangle, 4 by 5, it gives you 3. So B is tan inverse 3 by 4. It means cos inverse 4 by 5 can be written as tan inverse 3 by 4. Now, this whole thing we'll write in terms of tan inverse. We have already got it. Now, when we apply, what you observe, say for example, if you want to apply tan inverse x, tan inverse y, what we observe, take the product x and y. X and y, you find that they are positive and their product is more than 1. If the product is more than 1, we'll take the second case. It is pi plus tan inverse x plus y upon 1 minus xy. Be very sure. So whenever, before you apply, you please find out what are x, what is y, and what is the product. And accordingly, you choose the formula or the property. So we have written in this form now. And after you simplify, it gives you what? Tan inverse 63 by minus 16. And we know tan inverse minus theta is minus tan theta. So we can write pi, it is minus tan inverse 63 by 16 plus tan inverse 63. They get cancelled. So ultimately we get the value as pi. So this is the answer. This is how we'll be applying the properties. So while applying the properties, you must be very sure about the domain or the values of x and y. Now another property is what? Sine inverse. They are all in terms of tan inverse. And the same formula which we have learned in class 11, the same, like we know that sine 2x is equal to 2 tan x by 1 plus tan square x, the same way. So sine inverse 2x by 2 tan inverse x, again you must understand the domain part. Now we'll be proving one. So tan inverse x, let us assume that it is y, so x is tan y. Now x is less than equal to, mod x is less than 1, it means it is minus 1 to 1. So what will be y? So y has to be from minus pi by 4 to pi by 4. Because tan inverse y, tan x is, if tan inverse 1 is pi by 4, tan inverse minus 1 is again pi by 4. So it has to be minus pi by 4 to pi by 4. Now if you multiply the whole infinity by 2, so it gives you what? 2y is from minus pi by 2 to pi by 2. Now we know the formula. We can write sine 2y as 2 tan y 1 by 2 tan y by 1 plus tan square y. So what is tan y? X we have assumed. So it is 2x by 1 plus x squared. So 2y is sine inverse 2x by 1 plus x squared. Now again, y means 2 tan inverse x. So here again we have written Sine we have taken this side by observing that this 2y lies within the principal value branch of sine inverse, which is minus pi by 2 to pi by 2. So we have written this one. Now see, evaluate tan 2 tan inverse. So we know that tan is there, so inside the bracket it should be tan inverse. There should not be anything here. And we know now that 2 tan inverse x can be written as tan inverse 2x by 1 minus x square. So that will write 2x by 1 minus x square. After simplifying, it gives you what? Tan inverse 15 by 8. So now tan of 2 tan inverse 3 by 5 can be written as tan of tan inverse 15 by 8. And again it is principal value branch. In the first two properties we have learned it. So tan inverse, they will get neutralized and we will be getting the value of 15 by 8. So these are some properties. There are some more properties which has been given in your question. Try to understand that. In case of any problem, you must get it clarified. Thank you very much.